Okay, algebra, we're going to do 11-7, mixed expressions and complex fractions. Sound like fun? Great. All right, well, you just sit back, get ready, and here we go. Mixed expressions just means that it's like a number plus some kind of fraction. Okay? And you know how to do that. What are the two magic words we talked about in the last lesson? Common denominators. Okay? What's the denominator here? Well, you know it's 1. What's the common denominator between x and 1? It would be x, right? Or it'd be this times this. And so I multiply this by 1 and this by x. And I have to multiply by x over x. Does that make sense? I'm multiplying by 1. So I end up with, if I rewrite this, x over x plus 1 over x. Common denominators now. Numerator adds to numerator. And I keep the same denominator. So x plus 1 over x. Does that make sense? Here's a little tricky question. Can you cancel the x over x? You know that you can't, right? That's not a factor of this. It's just one of the terms. You could break it down into a simpler way. What if it was 2 over 1, 2 plus 1 over 2? Can you cancel that? Well, try it out. It doesn't work. 2 plus 1 is 3 over 2. That's 1.5. If you cancel that, it suddenly becomes 1. You know that's not going to work. So don't make the mistake of just canceling just because you see something that's above the other thing. All right? What if it was a little more complex? Oh, I don't know. Let's see. Is there one? Look at 1b. It's on page 720. It says 6y over 4y. Is it plus 8? Plus 8. And then plus 5y. Oops. And it's 5y, but you know it's 5y over 1, okay? So again, with the common denominator thing, it's going to be this times this. So basically, when we multiply everybody here by 4y plus 8. 4y plus 8. I now have a common denominator on the bottom. This is going to turn kind of complex. Let me just rewrite it. 5y times 4y is going to be 20y squared. 5y times 8 is 40y. But then I still have a 6y that I'm adding to that, so I'm going to make it 46y. And that's it. Over, here's my common denominator, 4y plus 8. Okay, do you see how that works? I'm looking to see if I can cancel anything. There's a common, what is it? 2y in the top, but there's not a common 2y down here, so I can't cancel anything, so I'm basically done. Okay? All right. Now, let's talk about complex fractions. That shouldn't scare you either. That's just like if they wrote it 1/2 divided by 2/3. Well, that's no big deal. Just because they write it like that, don't let it freak you out. It's just a divided by sign. So if you wrote it this way, you would know what to do. 1/2 divided by 2/3. Well, you know you flip that one and you make it multiplication. Well, you do the same exact thing. So flip this one, makes it 3 halves, and it'll make that multiplication. And then you just go top times top, bottom times bottom, and I would end up with 3/4. Okay, does that make sense? Occasionally there'll be something that you can cancel. Let's do probably the hardest one we'll do for this section. it's example 4 on page 722. Let's try that real quick. So it just says 2 over y plus 3 over 5 over y squared minus 9. 5 over y squared minus 9. Okay, so first thing I'm going to do is let's write that out. And it's going to be this divided by this. So really what I'm going to do is I'm going to flip this and make it multiplication, right? So times y squared minus 9 over 5. Okay, do you see how we got to this point? Now, it might look like we're just going to multiply those, but let's think about what we learned before. We learned about that cross canceling, and I can see that this is a perfect square minus a perfect square. So I'm going to rewrite that as the difference of two squares, which is y, it's the square root of that one plus the square root of that one, and the square root of that one minus the square root of that one. So it's going to be y plus 3 times y minus 3. Okay? And now do you see the reason why doing that is now I can cancel y plus 3, y plus 3. I can't really cancel anybody else. So when I do the distributive property on the top, it's going to be 2 times that, 2y minus 6 over 5, and then I'm done. Okay, hope that made sense. I think that should be pretty straightforward.